What is going on, guys? Welcome back. In this video today we're going to learn how to easily turn our machine learning model into a usable API. So let us get right into it. Alright, so we're going to learn how to turn our machine learning models into APIs using FastAPI in Python today. Now, the reason behind this is that oftentimes when you train a machine learning model and it performs well, it makes good predictions, you don't want to just hand that model to the user. Maybe because you want to sell it, or because the user doesn't know how to work with the model. Not everyone is a computer scientist or programmer. Not everyone knows how to use the model and load the data set and so on. So usually what you do is you make the model part of an application. So there's a feature or there's an endpoint in your application that uses the model, or in the simplest way, you just provide an API interface to the model. So API, already the I stands for interface, so saying API interface is redundant, but you can provide an interface in the form of an API to your model. And one very easy way to do that is using FastAPI. This is what we're going to do in this video today. What we're going to do specifically is we're going to train a simple machine learning model to classify handwritten digits, and then we're going to make that model accessible using an API. So this is going to be a very simple example here. For this, we're going to open up the command line and we're going to install 4 packages using pip, so pip or pip3 install. And we're going to install, first of all, of course, FastAPI, then also Unicorn to run the application, then also Pillow to work with images, and also scikit-learn to do the machine learning part. Once you have all of this installed, we can go ahead and create a Python file to train the model. So let's call this train model.py, and here we're just going to build our model. This is not going to be any part of the API yet. This is just going to load the data set and train a simple random forest classifier on the data set. So we're going to say here from sklearn.datasets import fetch openml. Then from sklearn.ensemble, we're going to import a random forest classifier. And from sklearn.model selection, we're going to import the train test split so that we can have a train and a test set so that we can also evaluate the performance of our model. And at the top, we also want to import pickle for serialization because, of course, we want to export our model so that we can use it in the API. So the first thing we do is we say x and y is going to be equal to fetch openml, and the dataset that we're going to use is the MNIST dataset, MNIST 784. I think that's 28 times 28 because of the pixels, so 784 pixels. We're going to say version equals 1, and we're going to say return x and y true so that we get it as a tuple x and y here. All right, so that is our data, and now we can split that into xtrain and xtest, into ytrain and ytest. That is going to be the result of the train test split applied onto x and y with a test size of 0.2. So we have 20% test data, 80% train data, and then our classifier will be a random forest classifier. And I'm going to provide here n jobs is going to be equal to -1 so that we can use all CPU cores for the training to speed it up, because otherwise it's going to take quite some time. And then we're going to do clf.score, xtest, and ytest. Actually, first of all, I forgot to do the fitting. So clf fit, xtrain, and ytrain. And then we're going to evaluate this on xtest and ytest. And finally, after this, we're going to say with open MNIST underscore model pickle in writing bytes mode as f. We're going to say pickle dot dump clf into f. There you go. So the file stream f and the classifier clf. So we can run this now. This is going to train the model to do the handwritten digit classification. This is not anything new on this channel. We have multiple videos here, or I have multiple videos here where I show you how to do that. I have, I think, 2 or 3 videos where I show how to do specifically handwritten digit recognition, and we have many more machine learning tutorials. This is just a simple part. Now we're going to take this model once it's trained and export it, and we're going to turn it into an API using FastAPI. And then we're going to also build a simple HTML page that is going to work standalone. Of course, in a real application, you would have a front end or something. We're just going to use a simple HTML file to access the API. but you could also do it in the command line if you want to. So I'm going to run now, or I'm going to create now a Python file that I'm going to call main.py. And here I'm going to import the following things. First of all, IO, which is a core Python package. Second of all, pickle, which is also a core Python package. Then numpy as np. I think numpy should be already installed as part of scikit-learn. If not, just install numpy as well. Then we're going to import pillow, so pil dot image. Actually, no, image ops, sorry. And then also from pil, we're going to import image, or actually, let's just go ahead and do it like this. Import pil image and import pil image ops. And then we're going to say from FastAPI, import FastAPI file and upload file. Now, FastAPI works with type hinting, so we need to specify what kind of file types or what kind of parameter types our parameters have, data types parameters have. And then we're going to say from FastAPI.middleware.cors, which stands for cross-origin resource sharing. And this is now only important for the demonstration in this video because I'm going to send a request to the server that is running from an HTML file, and it's not going to allow it because it doesn't have the proper origin. But to circumvent all of this, I'm just going to allow all the origins, all the methods, all the headers, and so on, which is why we need the course middleware. All right, so these are the imports. Then we're going to load our trained model, which is the MNIST model we just trained. So MNIST model pickle file, reading bytes is f, and then we're going to say that the model is equal to pickle load, and we're going to load the content of f. All right, so then let's create our API. We're going to say app equals FastAPI, very similar to Flask here. Then we're going to say app add middleware, and here we're going to now add the CORS middleware, and we're going to say allow underscore origins is going to be equal to a list containing an asterisk. Then I'm going to copy this, and we're going to change this here to credentials. First of all, is going to be equal to true. I don't even know if I need all of them. I just brute force it here, so methods is going to be equal to asterisk as well. And then finally we had headers as well. There you go. So this is just so I can send requests using the HTML file. Now, the actual endpoint, the actual API function here will be the following. We're going to say app, so @app, like a decorator, post, and we're going to have the URL pattern here predict image. And the function here is going to be an asynchronous function. So async define the function predict underscore image. And this is going to take a file as a parameter, which is going to have the type upload file. And we're going to say this equal to file and then 3 dots here. So this is just a type hinting. This is important for FastAPI. Now in Python itself, type hinting is not important other than for readability and for other tools. But in the case of FastAPI, the type hinting is actually relevant and necessary. So contents that we get here from this file is going to be equal to await file.read. So we're going to wait for the file to be read. This is then going to be our content. And now we're going to extract the image from that content. We're going to say the pillow image is going to be equal to image.open. And now we're going to get the byte stream io.bytes.io contents like this. And we're going to convert this to grayscale. So to an L. In my case, the images that I'm going to pass are going to be already grayscale. Of course, here we need to say pill.image, not just image. And I think, does this work? Why is it underlined? Actually, like this. There you go. Yeah, like this. So we open the byte stream of contents, and then we convert that to grayscale. That's what we're doing here. Now, since the way that scikit-learn processes the images and the way Pillow processes the images is slightly different, we need to also invert it. So we need to turn black into white and white into black and so on. So we're going to say Pillow image is going to be equal to pill image ops dot invert, at least if you want to have the digits like this. Otherwise, an easy way, if you don't want to invert, is you can just draw them white on black. This is also possible. So image ops, and then we're going to do invert the pillow image. Then we're going to say pillow image is equal to pillow image dot resize. In the case you don't pass a 28 times 28 pixels image, which I'm not going to do, I'm going to pass the proper size already. You want to resize this, and you want to do that with anti-aliasing. So pillow image anti-alias. Why doesn't this work? Anti-alias. Shouldn't this work? I think it should. Let's see if it produces any problems when I run this. Then we're going to say the image array is going to be equal to numpy array of the image, so of the pillow image. And we're going to reshape this like this. And then we're going to feed our image into the model and get a prediction. So we're going to say model predict image array. And then we're going to return the following dictionary. The key is going to be prediction, and the content or the value is going to be the integer of prediction 0, like this. All right, so this is now our API application. Before we can use it, though, we need to somehow write an application or a website or an HTML page that uses it. Of course, you can also use it with curl, but we're going to create an index.html file, which is going to be our front end here. In an actual application, you would have a separate front-end application that calls the API, or you would have some tool that calls the API. But we're just going to keep it simple and create an index.html file here. And what we're going to do here, let's call this image classifier, or actually digit classifier. What we're going to do is we're going to have a form. Or actually, we don't need a form even. We can do everything with JavaScript, or we have to do everything with JavaScript. We're going to say input type text is going to be an input, or actually not text, sorry. This is a file, obviously. We're uploading an image, not text. Input type file will have the ID image input. And we're going to accept all kinds of images. So image slash, and we don't want to limit ourselves to a specific type here, so we're going to just go with an asterisk. And then we want to have a simple button, and this button is going to call a function, a JavaScript function that we need to write to upload and send the image, and to also process the response for the given image. So I'm going to say button on click is going to be equal to upload image, which is a function, and the button will have the text upload, or let's call it classify, like this. And then below this button, we want to have an element with the ID prediction result. And by default, it's going to be empty. But when we press the button, when we call this function, it's going to fill it up with information, provided that the request succeeds. So we're going to now write the JavaScript section here. We're going to say script type text JavaScript. And we're going to define our asynchronous function here. Async function upload image. Now we need to use curly brackets since we're not in Python. I'm going to say that the input element that we're interested in is document.getElementById image input. So we're accessing this particular input here. And what we want to do is we want to say if input.files 0. So if we have a file here, then of course we're going to process it. Otherwise, what we're checking here is if there's not such a file, we're going to just do it simple and call an alert. Please select a file to upload. And we're going to return. Otherwise, we're just going to say constant file is equal to input files 0. So we're going to get that file, which is existent. And we're going to say form data is going to be equal to new form data. And we're going to say form data append file. So we're sending the file to, we're creating a form, but we're doing it in the background asynchronously, so we're not going to actually post and then reload the page or be redirected. We're going to do everything here in the background, which is why we create form data. We append the file to the form data, and then we're going to try to send a request to our API. So we're going to do try, and we're going to say const response is equal to await fetch, and we're going to now access, in our case, since this is running on localhost, http://127.0.0.1, so localhost, on port 8000, which is the default FastAPI port, and the endpoint was predict image, which is this one here. So that is the URL, and what we want to do here now is we want to specify the method post, and the content, the body, is going to be the form data. So this is what we're actually passing, what we're actually posting to the endpoint. That is what we do. Now what we do is we say the result is going to be equal to await response.json. So we want to get the JSON version of the response. Remember, we get a dictionary here with prediction. And then we want to do document.getElementById, prediction result, which is our paragraph up here. That should display the result. We're going to say text content of this is going to be prediction, and then dollar and curly brackets result.prediction. So since this is a JSON object, it's going to have the field prediction. We're going to get the prediction and display it here in the paragraph. Right, so in any case of an error, so if some error happens here, we're going to catch it, and we're going to just log it to the console as an error message. So we're going to say error, and then error, like this, and then we're going to say alert failed for some reason. Doesn't really matter. And that is now our logic in the front end. The most important part actually is just getting some image data and posting it to the backend. So this is actually the whole magic. This is just sending this to the backend. Everything else is getting the data and showing the result here. So that is the magic here, sending the data to the actual endpoint. So I can run this now, and if I didn't make any mistakes, of course I cannot just run it like this. We need to open up a terminal. Can I open a terminal here? There you go. Current. Now I can say uvicorn. Let me just see the proper command here. Uvicorn main, and then also the name of our app. Main is the name of the file, and app is the name of the app. This is what we created here, the FastAPI app. And then -- reload to don't have to constantly restart the application when we make changes. And then I want to open up my index.html file in the browser. So there you go. We have our index.html file here. Now I can browse for a file, and I can open, for example, digit 1 and classify it. And you can see it has the prediction 5, and you can see it is actually a 5. So digit 2 should be an 8. There you go, 8, and digit 3 should be a 3. There you go, 3. So yeah, we turned our machine learning model into an API that we can use in the browser. Of course, you can make this much more professional by using a proper front end and a proper API with different functionalities and so on. But this is how simple it is to just take a pickle file, the exported version of your model, and to put it into an API, because actually the whole API is this. And you don't even need that if you don't want to just play around with it. In fact, this is not recommended in an actual application. I just did it so that I can send the request. But the whole magic is this here and loading the model. That's it. And once you have the model, you can easily do that. And then you just have to write some front-end code to actually use it. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.